Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. When troubleshooting network problems, it's essential to choose the right tool for the right type of issue. A problem caused by a down interface won't be fixed with routing changes, and a DNS misconfiguration won't be uncovered by checking physical cables. Every network challenge exists at a specific layer of the OSI model, and each requires targeted diagnostic tools. Whether you're dealing with a faulty interface, a misrouted packet, or a platform-specific error at the operating system level, matching your method to the problem saves time, improves accuracy, and reduces frustration. Guesswork is the enemy of efficient diagnostics. In this episode, we focus on three interconnected areas of network diagnostics: interface-level troubleshooting, routing verification, and platform-specific commands for both client devices and infrastructure hardware. These tools and techniques give you insight into how packets enter, move through, and exit your network. Whether you're studying for the Network Plus exam or performing real-world support, mastering these diagnostic categories helps you quickly isolate root causes, verify configurations, and get systems running again with confidence. We begin at the physical and data link layers with interface diagnostics. These include verifying the link state of a network port, reading interface counters, and checking physical port configurations. Common issues at this layer include down interfaces, speed mismatches, excessive errors, and damaged cables. Indicators such as status LEDs, port state in a switch console, or unexpected link flapping all point to potential Layer 1 or Layer 2 faults. Diagnosing these early prevents you from misattributing a simple interface issue to a more complex routing or application problem. Interpreting interface counters is a vital skill. CRC errors, or cyclic redundancy check failures, suggest problems with signal integrity, usually caused by bad cables, bent connectors, or EMI interference. Input or output errors can point to congestion or buffer overruns on busy ports. Collisions, though rare in full duplex environments, are a red flag for duplex mismatches. Monitoring counters over time allows you to see whether errors increase steadily or occur in bursts, helping distinguish between chronic and one-off issues. The more familiar you become with these indicators, the faster you'll identify the root cause of link performance problems. The most common CLI commands for interface troubleshooting include show interfaces, which displays status, speed, duplex, and counters; show status or show port, depending on platform, which gives quick overviews of each interface's state; and show running MOG to verify whether a port is enabled, shut down, or configured correctly. These commands are typically issued on switches and routers, but apply across many platforms. Knowing where to look and what to interpret is a core troubleshooting skill. Routing table verification is the next step when the physical interface is confirmed, but communication still fails. Using the command show IP route, you can see which networks a device knows how to reach, how those routes were learned, and which interface will be used to forward packets. If a route is missing, misconfigured, or superseded by a lower administrative distance, traffic may be dropped or misrouted. This is especially common in environments with overlapping static and dynamic routes, or when a change in topology causes a routing update to be missed. Checking routing protocols like OSPF, EIGRP, or BGP is also essential in dynamic routing environments. Commands such as show IPoff neighbor, show IPIGP summary, or show IPIGRP topology allow you to confirm that neighbor relationships are established and stable. Routing loops, flapping routes, or missing paths often stem from failed adjacencies, misconfigured areas, or inconsistent timer. Debugging these issues may require temporarily enabling protocol-level logs or using packet captures to analyze hello messages, keep alives, and route advertisements. Static route troubleshooting brings its own challenges. Common mistakes include specifying an incorrect next hop IP address, using the wrong destination subnet, or unintentionally overriding a dynamic route due to lower administrative distance. When static routes don't work, start by verifying interface reachability to the next hop using ping and trace a route. Confirm that the specified network is in the correct subnet and that there's no firewall or ACL blocking traffic. Even one mistyped digit in an IP address can break a static route, and unlike dynamic protocols, static routes won't self-correct. Some issues aren't related to routing at all, but instead stem from incorrect gateway or DNS settings. If a device has the wrong default gateway, it may be unable to reach external networks, even if the internal routing is correct. Similarly, a DNS misconfiguration means that even though IP-level communication works, domain names fail to resolve. This is one of the most frequently misdiagnosed issues on both exams and in the field. Always verify DHCP settings or static configurations to confirm that the default gateway and DNS servers are correct for the subnet. Platform-specific diagnostic tools are also critical. On Windows, commands like ipconfig, netstat, nslookup, and tracert provide insight into address configuration, active connections, DNS queries, and routing paths. On Linux systems, equivalent commands include ifconfig or IPA for interfaces, netstat or SS for sockets, dig for DNS, and traceroute for path analysis. Network devices from Cisco, Juniper, or other vendors offer specialized commands for interface status, routing protocols, and system health. Technicians must be comfortable moving between these platforms and adjusting their approach accordingly. Finally, logs provide invaluable support for diagnostics. On network devices, show logging displays recent system messages, including interface state changes, routing updates, or protocol errors. On Linux, DMESG shows kernel-level messages and /var/log/syslog or /var/log/messages provide broader system event tracking. Reviewing startup messages, interface state transitions, and service logs can reveal the exact moment something went wrong or confirm that a change occurred that triggered the issue. Logging isn't just for auditing. It's a frontline diagnostic resource that bridges CLI analysis and long-term monitoring. For more cyber content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Diagnosing DHCP issues is one of the most common tasks in network troubleshooting. When a device fails to obtain an IP address, users are often left without any connectivity. The first step is confirming that the DHCP server has available leases within the defined scope. If the scope is exhausted or the server is unreachable, no IP address will be assigned. On Windows systems, running ipconfig/renew can manually trigger a new request, while reviewing the DHCP server logs helps confirm whether the request was received and why it may have been denied. A device stuck on a 169.24xx address indicates failure to obtain a lease, usually due to server unreachability or filtering. Firewalls, especially those integrated into operating systems, can also block traffic in subtle ways. On Windows, Windows Defender Firewall may restrict access based on application, profile, public, private, or domain, or port. A rule may silently block inbound SSH or outbound ICP, making diagnosis difficult if you don't check firewall settings explicitly. On Linux, IP tables or newer systems like firewalled manage access control rules. A rule that drops packets or restricts protocols can look like a routing or DNS issue unless properly diagnosed. Use CLI commands to view the current firewall rule set and ensure required ports are permitted. At the link layer, verifying address resolution protocol and neighbor discovery protocol (NDP) entries provides clarity when communication fails between devices on the same subnet. ARP, used in IPv4, maps IP addresses to MAC addresses. If a device lacks an ARP entry for a destination IP, or if the entry is incorrect, packets won't reach the correct recipient. Similarly, NDP performs this function in IPv6 networks. Commands like ARP-A or EPNA display current mappings. If an entry is missing or invalid, clearing the cache or restarting the interface can force regeneration. These steps help resolve what may otherwise appear to be higher-level failures. The diagnostic and debug modes on routers and switches allow real-time protocol-level visibility. Enabling debugging for a specific protocol, such as debug IP OSPF events, displays live messages about what the device is doing and why. This can help catch routing neighbor failures, authentication mismatches, or keep alive timeouts. Verbose logging options enhance visibility but should be used carefully. They generate a large volume of output and can tax system resources. Always use debugging temporarily and disable it after collecting the necessary data. Debug output is most useful during replication of a specific issue or when testing changes. Ping and traceroute remain staple tools in any diagnostic workflow. Ping verifies basic reachability and latency, while traceroute or tracesearch shows the path packets take through intermediate routers. Together, they confirm whether the issue lies in basic IP connectivity, upstream routing, or beyond. If a ping to the gateway succeeds but a ping to the internet fails, the issue likely lies in routing or DNS. I realized, when the story if traceroute stops after a few hops, it may indicate a routing loop, firewall block, or upstream failure. These tools are even more powerful when combined with interface-level data and logs, offering a full view of what's happening. Isolation techniques are key in narrowing down the exact cause of a problem. By isolating the issue by OSI layer or network segment, technicians can eliminate potential causes one by one. For example, if a device cannot connect to a remote server, start by checking local IP configuration, then verify DNS resolution, then test the route to the server. At each step, eliminate what's working so you can focus on what's failing. Isolation also applies geographically. If multiple users in one area are affected, the issue may lie with a switch or access point. If it affects only one user, focus on their interface and configuration. The Network Plus exam includes several diagnostic scenarios that test your ability to interpret command output, recommend the correct next step, or choose the right tool for a given issue. You may be shown a partial show IP route output and asked to identify a missing route. Or you may see ARP entries, interface errors, or DNS failures and need to choose which layer to investigate next. The exam favors logical progression and tool matching over raw memorization. Being familiar with how CLI output correlates to real-world behavior will make these questions more manageable and intuitive. To summarize, network diagnostics spans several layers, each with its own tools and techniques. Each level troubleshooting includes link status checks, error counters, and port settings. Routing diagnostics involve verifying routing, tables, dynamic protocol adjacencies, and static route accuracy. Platform-specific diagnostics include commands for IP configuration, DNS lookups, firewall checks, and ARP or NDP analysis. Across all of these areas, logs, debugging tools, and isolation techniques help pinpoint the root cause. Mastering these tools allows technicians to respond to problems faster and with greater accuracy. Understanding the distinctions between interface errors, routing faults, and operating system-level misconfigurations is key to successful troubleshooting. It means knowing when to escalate, when to dig deeper, and when to trust the output in front of you. With practice, you'll learn to recognize patterns, interpret counters and logs, and make fast, informed decisions. These are the core competencies of every effective support technician and network administrator, and they're central to both real-world operations and exam success. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.